Hi folks, so this is question 3. So it's a circle question. So part A, the circle has this equation, the radius is 5 root 3, so you have to find the value of k. So the general formula for a circle, I'm going to use this one here, and this is in your log table, so plus 2gx plus 2fy plus c equals 0. So that's general format, and then in their log tables as well they give you a formula with g's, so I'm using the g's and f's ones here. I think it'll be easier. So r is equal to, so r is the radius, is equal to g squared minus, or sorry, plus f squared minus c. So that's a formula for the radius when the circle is in that format up there. So we need to just put in then, so 5 root 3 is the radius that's given to us, and then we need to see what g is. So you can see there that 2g would have to be minus 2, because that's what's in front of the x in the circle. So 2g is minus 2, therefore g is minus 1, so we're putting in a minus 1 instead of g, so minus 1 squared. And then similar enough with for f, you're looking at what's in front of the y, so there's an 8 in front of the y, so 8 has to be what 2f is, so 2f equals 8, therefore f is 4. So we're putting in a 4 instead of the f in the formula then, so 4 squared minus c, and in this case minus c is, so it's minus k really, because c is k in the question. Then because you've got roots on both sides, you can just square both sides. So if you do 5 root 3 all to be squared, you should get 75, and then this is just going to be 1 plus 16 minus k, because the big square root is gone. If you add 1 and 16 together, you get 17, and then take that away from the left hand side, you get 58 equals minus k. So if minus k is 58, just multiply across by minus 1, so k is minus 58. And that's part A. Let's look at part B then. So there's a different circle now, so circle x minus 5 squared plus y plus 2 squared equals 20 has a tangent at the point 9 minus 4. So you can do a little sketch of that straight away anyway. You know that the center has to be the point 5 minus 2, okay, because you take the opposite signs of what's inside the brackets really. So that's what h and k would be. So 5 minus 2, so 5 minus 2, we'll just pretend it's over here, so roughly. So that's the center of the circle, and it has a tangent at the point 9 minus 4. So that's 5 minus 2, so 9 minus 4 would be over another bit and down a bit, so we'll just say there. So the circle then would, if it has a tangent there, that has to be on the circle. So the circle very roughly would be kind of something like that, and this is our tangent. Right. So really what we're going to do is we're going to find, we have a point, so we're going to ultimately be using this formula, y minus y1 equals m by x minus x1. So we're looking for the equation, oh no sorry, we're only looking for the slope actually. Oh yeah, we're only looking for the slope of the tangent, so I don't need that. So the slope of the tangent, what we're going to do is we're going to find the slope of this line through those points, and then because that red dotted line there is perpendicular to the line that I want, we're just going to do minus the reciprocal of it, and then that has to be the slope of the tangent. So let's find the slope of the line through the points 5 minus 2 and 9 minus 4. So that's y2 minus y1, this is from the log tables as well, over x2 minus x1. So x1 or y1, x2, y2. So minus 4 minus minus 2 over 9 minus 5. So that's going to be minus 2 over 4, so that's minus 1 over 2. So that would be the slope of that red dotted line there. So just of this line here, that's the slope of that line. Now because it makes a right angle with the line that I want, you can do minus the reciprocal of it. So minus the reciprocal would be just 2 over 1, or just 2. So 2 has to be final answer there then. So 2 is the slope of the tangent. Then let's look at part C. So we've got two circles, so each of them are on the axis, alright, so we can use that then. So if you think about what the center would be here, that's going to be the x-coordinate of the center is just going to be what the radius is, because it has to go from the y-axis out, and then similarly down here, so you have to go across r and then down to minus r basically, because you're going down to the minuses. So r minus r would be the center, and then similarly here for the small one, that's going to be the same thing really. It's going to be, you have to go r and then minus r, so we can use that, and the point 1 minus 8 is on the circle. So let's just write down the equation of the circle. So x minus h squared plus y minus k squared equals r squared. So I'm going to sub in r and minus r in instead of h and k. So x minus r squared plus y minus r squared equals just r squared. So let's multiply out the brackets. We get x squared minus 2 rx plus r squared plus y squared. That will be a plus r in there, so it's just y plus r squared out, so plus 2 ry plus r squared equals r squared. So we get a few r squareds here, so we can cancel out that one and that one because they're on both sides. So we get x squared minus 2rx plus r squared plus y squared plus 2ry equals 0. Let's sub in the point. So the point 1 minus 8 is on both of the circles, so we're still keeping it general for both of the circles if we sub in 1 minus 8, because 1 minus 8 should work for both circles. So 1 minus 8 so we get 1 squared minus 2 times r times 1 plus r squared. So r is going to be our only variable that's left, hopefully, if we do this right, plus minus 8 squared plus 2 times r times minus 8 equals 0. So 1 minus 2r plus r squared plus 64 minus 16r equals 0. So we just need to be careful. Plus 65 is what's left with the constant. We get r squared. There's no other r squareds, and we're going to get minus 18r equals 0. So we're going to end up getting two values for r, and that will be the two different radiuses then. That'll be that one and that one. So that's what we're going to end up getting. We're going to get two values for r, and the two values will be both of those. So we've just got a quadratic. We just need to find two numbers that multiply to give 65 and add to give minus 18. So r equals 0. So 65, you could have 1 times 65, or you could have, I think, 5 and 13. 5 and 13 are going to be the ones. and then they're both going to have to be minus, because they must multiply to give a positive, and they're adding a minus 5 take away 13 then is minus 18, so that works. So r minus 5 equals 0, r minus 13 equals 0. So r equals 13, or r equals 5. So r has to be one of those, therefore that's helpful then. So that r equals 5 has to be this one here, and 13 has to be this one here. So the two circles then will have to be, remember the center now is for the big one, so let's do the big one first. So the big circle, the center will be 13 minus 13, just by definition there, and r will be 13. So radius is 13, so it's going to be x minus 13 squared plus y minus minus 13. Okay, so minus minus 13 is plus 13 squared, so it's the opposite signs really of what h and k are there, equals 13 squared, and 13 squared is 169. That's the big one, and then the small one, that has to be the 5, so it's going to be, similarly enough, it's going to be 5 minus 5 will be the center, and 20 yeah, 5 is going to be the radius as well, so it's going to be x minus 5 squared plus y minus minus 5, so it's going to be plus 5 squared equals, and then r squared, which is going to be 5 squared, which is 25. So there are two answers then, or two final answers, so I just wrote them up there. But it should be that, I should write them down below obviously, but those are your two circles. So that's everything for that question.